Now, just broadly, our antimicrobials are fantastic. They've saved millions of lives. We've come to rely on them utterly. There are two big drawbacks with them. The broad spectrum antimicrobials, that is, ones that are capable of killing a lot of different bacteria, gram-positive, gram-negative, loads of different species of genus of bacteria. Those broad-spectrum antibiotics, the more broad-spectrum they are, the more likely they are to knock out your normal flora. That is, the normal bacteria that colonize various little nooks and crannies of your body. Now, what you have to remember here is that most bacteria that exist in the world don't actually cause us a problem. They don't cause disease. The ones that do cause disease are in a minority. And our bodies are colonized with more bacteria than we actually have human cells. In other words, when you look at yourself, you should consider that you're looking at more bacteria than you are looking at yourself. We were colonized by billions and billions of different bacteria, and a lot of them are actually protective or not harmful, and some of them are actually useful. But when you use a broad spectrum antibiotic to destroy one particular bacteria that is a disease-causing bacteria, you will also kill all of the good ones or the harmless ones. And the problem with that is that it leaves you open to infection by a particularly resistant bug or a rapidly growing bacterium. Not necessarily just a bacteria either, it could be fungus or anything else, because that competition between your normal bacteria that normally colonize your body, that normal competition will prevent the dramatic overgrowth of any one type of bacteria. So while they're all there muddling together, rubbing shoulders and fighting for resources and so on, none of them are allowed to become dominant to the extent that their numbers become a problem for you. If you knock them out or knock some of them out, then you have a problem potentially with another type of bacteria or even a fungus overgrowing. Often antimicrobials will cause diarrhea and gut upsets because of the wiping out of useful bacteria in the large intestine. You can see it when women have a course of broad-spectrum antimicrobials, that they might then get thrush, vaginal thrush. That's an overgrowth of a yeast because of the loss of the normal flora that inhabits the vagina and would keep down the growth of the yeasts. So that's one problem that has always been there with the antimicrobials, but it's dealable with. The second major problem is one which started to emerge not long after the antimicrobials really started being used, and is now becoming a major problem because we're now having bacteria that are disease-causing and cause many cases of disease worldwide, now emerging with multi-drug resistant strains. So the development of resistance of the bacteria that we have previously been able to treat very effectively with these antimicrobials is going to lead to an increase in the number of deaths due to infection that we haven't seen for a long time. We've got used to the idea that people don't tend to have to die from bacterial infections, and I think we've tended to start to think, well, that's because bacteria don't have the capacity to kill us. They certainly do. So those are the two major issues with antimicrobials. Now, on top of that, of course, no antimicrobial is a true magic bullet. They all have some adverse effects, they all have some potential to cause toxicity, but that will vary between the different types of antimicrobials. And we're not going to go into any one class in any detail at all, but as usual what we're going to do is just have a quick look across the classes and note any standout differences or adverse effects that a particular class has. This bacterium, Clostridium difficile, is normally resident in the gut, and this is one of the problems related to the knocking out of the competition that we were just talking about. And I mention it specifically because it is a very dangerous one and can easily cause death. So basically, if Clostridium difficile is allowed to reproduce unchecked in the gut, it can cause this disease, pseudomembranous colitis. And pseudomembranous colitis looks like this. So those yellowy kind of lumps are what they call the pseudomembranes inside the large intestine there. And the risk associated with that, it will give you nasty diarrhea. The risk associated with that is toxic megacolon and what happens is the colon essentially becomes paralyzed, the motility is reduced, and it gets larger and larger, and of course can actually rupture. Now, that bacteria obviously is able to overgrow when you knock out other bacteria in the gut, and so it can be a problem associated with the use of a number of different antibacterial drugs, but it's particularly a problem with certain groups that we're going to look at. So clindamycin is a single agent that is known to have a particular liability for producing C. difficile infection and pseudomembranous colitis, as are the penicillins and the cephalosporins. And it's particularly a problem when people are being treated in a healthcare environment, in hospitals, but not just hospitals, it could be nursing homes or people's homes, because now the drug-resistant form of this bacteria can be spread in that environment. And so the likelihood of this infection, of course, is increasing, the risk of toxic megacolon, and I think I've got a graph here, yeah. So here's deaths caused by this infection over time, and you can see that this is deaths per million. So although it's not a huge number, it's steadily climbing. That's from the Centre for Disease Control in the States. So you can see that the opportunistic overgrowth causing a dangerous infection is becoming more of a problem because of the resistance and the ability to spread the bacteria between patients in hospitals, for example, and in other healthcare facilities. And I put this in because I thought this will help you to remember C. difficile. We've got Cliff. Now, I don't know if he's the only beagle who's been trained, but he can smell Clostridium difficile in healthcare environments. So he's trained to sit down, as the drug-sniffing dogs are at airports, when he gets a whiff of Clostridium difficile. So the idea is that these dogs would become very useful for helping to increase the infection control protocols in healthcare environments. And we have become rather lax with our infection control. In other words, rather than making sure that the bacteria is not around in the healthcare environment, you know, on various surfaces, that it's not being harboured in tubes and various other non-human places, we've tended to just rely on the fact that we've got these wonderful antibacterials. Well, now we have to go back to much better control of bacteria on various surfaces all around the place. We have to really go back to basics with making sure that things are properly sterilised. And a dog that can sniff out this particular bacterium would be incredibly useful. So that's Cliff. There he is, sniffing some Clostridium. And this is the other thing that has been used to treat Clostridium difficile infections with quite good success. These are, yes, frozen poop pills. So essentially, healthy donors have donated their poop, and the bacteria, the normal flora, that's your good bacteria, have been extracted and put into these capsules to give to people who have the Clostridium difficile infection. In other words, you're re-inoculating them with the normal gut flora that would normally keep C. difficile in check, and this has been quite effective. So you might say, yuck, I would never take a poop pill, but I think we'd all be popping them if that was the only option, if we had Clostridium difficile. So there's some hopeful signs in the form of Cliff the C. difficile sniffer and the poop pills.